In this video, we are going to learn about the prime factorization of numbers. Prime factorization is the process of breaking down a number into its prime factors. Now, what do we mean by factors? Factors are the numbers that are multiplied together to get another number. And what do we mean by prime? A prime number is a natural number which is greater than 1 and which has only two factors, 1 and itself. For example, the number 2, which has only two factors, 1 and 2. The next prime number is 3. 3 has only two factors, 1 and 3. The next prime number is 5. The prime number after that is 7. Then we have 11. We have 13. The next prime number is 17. Then we have 19. We have 23, and so on. So these are examples of prime numbers. Now, how do we find the prime factorization of a number? We can do that by using a factor tree. Now, what is a factor tree? Let us have a look at an example to understand that. So let us consider the number 12. Now, what we want to do is break this into factors. Now, we know that 12 is equal to 2 times 6. So we start drawing our factor tree like this. We have 2 over here and 6 over here, and this means that 2 times 6 is 12. Now we want to find the prime factors. So let us consider which one of these two is prime. Now 2 is a prime number, 6 is not. So what we're going to do is we're going to break down 6 further. Now we know that 6 is equal to 2 times 3. So this is what we get. And now let us have a look at what we have. We have 2 over here, we have 2 over here, and we have 3 over here. All of them are prime numbers. So we have used our factor tree to determine what prime numbers can be multiplied together to obtain the original number 12. So what do we end up with? We have our prime factors as 2, 2, and 3. And that just means that 12 is equal to 2 times 2 times 3. So this is the prime factorization. Now we have 2 multiplied by itself 2 times. So we can write that as 2 to the power of 2. And we multiply that by 3. So what do we have? We have these two 2's written as 2 squared. And we have this 3 over here. And if we write the prime factorization in this way, we say that this is written in exponential form. So the prime factorization of 12 written in exponential form is this, 2 squared times 3. Now note that we will obtain the same prime factorization of this number 12 no matter what factors we start with. That is, if we start with factors other than 2 and 6, we are still going to end up with the same prime factorization. So let's see how that's done. Suppose we start with the number 12, and this time, instead of using 2 and 6, we use the factors 3 and 4, because 3 times 4 is 12. Now, 3 is a prime number, so we are not going to break that down any further, but 4 is not a prime number, so we need to break that down. Now, 4 can be written as 2 times 2. And now we have ended up with prime numbers 3, 2, and 2. And that just means that 12 is equal to 3 times 2 times 2. So 3 times 2 times 2, and over here we have 2 times 2 times 3, which means that we end up with the same prime factorization, 1 3 and 2 2's. And we can write this in exponential form as 3 times 2 to the power of 2, because we have 1 3 over here, and we have 2 2's, which we write as 2 squared. So we have a 3 and a 2 squared. Similar to here, we have a 3 and a 2 squared. And that just means that we have obtained the same prime factorization. Now, this works for every other number as well. No matter what factors we start with, we will always end up with the same prime factorization. Now, let us have a look at a few practice problems. The first number we have is 45. Let us find its prime factorization. So we start with the number 45 and we start drawing the factor tree. Now 45 is equal to 5 times 9. Now the number 5 is a prime number, so we don't need to break that down any further. But 9 is not a prime number, so we're going to break that down. Now 9 is equal to 3 times 3. And now we can see that we have prime numbers, 5, 3, and 3. So 45 is equal to 3 times 3 times 5. And if we want to write that in exponential form, we have 3 multiplied by itself 2 times, so we have 3 squared times 5. So this is our required prime factorization. Now let us move on to the next number. Now the next number we have is 105. So let us start drawing a factor tree for it. Now 105 is equal to 5 times 21. Now 5 is a prime number, but 21 is not. So we need to break down 21 further. And we know that 21 is equal to 3 times 7. And now we can see that we have prime numbers 5, 3, and 7. So 105 is equal to 3 times 5 times 7. And that is our required prime factorization of the number 105. Next, we have the number 88. Now let us start drawing a factor tree for it. Now 88 is equal to 8 times 11. Now the number 8 is not a prime number. We need to break that down further. But 11 is a prime number, so we don't need to break that down any further. So consider 8. 8 is 2 times 4. And over here we have a prime number 2. We don't need to break that down any further. But 4 is not a prime number, so we need to break down 4. And 4 can be written as 2 times 2. And now we have all prime numbers. We have 2, 2, 2, and 11. And so 88 is equal to 2 times 2 times 2 times 11. And if we want to write that in exponential form, we have 2 multiplied by itself 3 times. So we have 2 to the power of 3, and we multiply that by 11. So this is the required prime factorization. Let us consider the next number. The next number we have is 27. Now let us start drawing a factor tree for 27. 27 is equal to 3 times 9. Now the number 3 is a prime number. We do not need to break that down any further. But 9 is not a prime number, so we need to break that down. And 9 is equal to 3 times 3. And so we have ended up with prime numbers 3, 3, and 3, which means that 27 is equal to 3 times 3 times 3. And if we want to write that in exponential form, we have 3 multiplied by itself 3 times, so we have 3 to the power of 3. And this is our required prime factorization. Thanks for watching this video. I hope you enjoyed it. Don't forget to comment, like, and subscribe. See you next time!